Welcome back to Things Top Notch Academy. So we're looking at loss of logarithm today. Before now, we've already treated the definition of logarithm, where I stated when it is in its logarithmic form and when it is in its what index form. That is when they are transferring from logarithmic form to index form, or from index form to what logarithmic form. And we will solve some examples. So do well to check the video. All right, so we're looking at the loss of logarithm today, just like as we treated loss of indices. We also have the laws that govern logarithm, and one of the laws that govern logarithm is what we call addition law. Addition law of logarithm. So this law of logarithm says that when you have a number that has division sign in between them, we have different log of this and log of that, and they have this addition sign in between them. So what you have to do is you change this addition sign to what is called multiplication sign. All right, so that's how you solve it. And the conditions that is attached to this is that it must have the same base. All right, the log must be of the same base. It must be of the same base for this work. So in this case now, we will have that addition will change to what? Multiplication. So the example of this is this. Let's say we have log of m to base a, then adding it to log of n to base what? A. You can see it now that they have the same base. Okay, this is one of the conditions you should consider. So if you have log of the same base as this added together, the answer that is going to give you should be log of a, that is log of m n to base a. All right, so what do I mean here? So what you did is you had log of m to base a, log of n to base a, then you collected one of the what bases. Okay, so because the base they are all same, so you just collected one, which is log a, then the powers are being what multiplied together, which is what you're having. So this same thing works when you have log of, let's say you have log of m multiplied by log of n. So in this case now, what you have to do is you collect one of the log, which is the base log of a, then the powers here must be what added what together. So this is what is going to give you as the answer when you have multiplication sign in between them. What this means is that when you have multiplication, it changes from multiplication to what? Addition. Then in the case where you have addition, it changes to what? Multiplication. So now let's go to the second law of logarithm. We're going to look at some examples that we need to apply these laws for us to get them. Okay, so let's state the second law. So the second law says the subtraction law. We call it subtraction law. Whenever there is minus sign in between the logarithm, we say we need to what? Apply division. Okay, that means now that subtraction changes to what? Division. Okay, that is the difference. Let's say we have log of a, log of what? M to base a minus log of n to base what? To base a. So when we have something like this, we need to apply the subtraction law of the logarithm, which means having log of m to base a minus log of n to base what? A will give us, so we should collect one of the base, which is log of a, then this power is going to what? be written this way. So we're going to have log of m, then divide by what? N to what? Base a. That is what we're going to have. The same applies when we have log of m, then divided by log of n to base what? A. So when you have something like this, what you need to do is the first one here, this division sign is going to change to what? Minus sign. Where we'll now be having log of m a, then minus log of what? N to base what? A. You see now that it has been transformed to the initial equation that we had before. We have the next law of logarithm, which we call the index law of logarithm. So this law, that's number 3, index law. So this law can also be called the power law. You know, you can call it power or what? Index. Power law or what? Index. So they are all same. So some call it power law of logarithm, some call it index law of logarithm. So whichever name you call it is still acceptable. So this law says when we have log of a to log of m to base a raised to the power of what? P. Okay, how do you solve this kind of law? It's very simple. When you see something like this, what you have to do is you take this power down, so it will multiply the whole log. So what I mean is this: you have log of m to base what? A. So here will now be what? P, multiplying this. All right, so that is how to solve it. So this power here will come down, then it will multiply the whole of this. So the example of this, let me just give you an example, though we are still going to solve numerous examples later. So the example here now is, let's say we have log of 2, 4 is to what? 3. You need to apply the index law of logarithm, where this, we call this the power. This is the power, all right? Or we call it the what? Index. That is the reason why you need to apply the index law of logarithm to solve this. So in this case now, if you want to solve this, it's going to give us, this 3 will come down, which is 3 log of what? 2 to 4. All right, but it not stop there. We can still solve further. There's another law of logarithm. I'll still come into it, but let me just solve this. So it will now be what? 3 log of what? 2. Here it should now be what? 2 is to what? 2. So this 2 now will also come down again. It will now be 2 times 3. That is 6 log of what? 2, 2. And this logarithm of the same base, which is 1. So it will now be what? 6 multiplied by 1, which is what? 6. So that's how to solve this type of logarithm. All right. But we're still coming to solve other examples. All right. So that is how you apply this law of logarithm. Now, there are some people that mistake this. I've seen some channels that says that when you have log of 2, 1 all over what? X, they say it's a new another law of logarithm. But this law of logarithm falls under index law of logarithm. All right, it's not a law of its own. It falls under the index law of logarithm. What I mean is this: if you are solving this type of logarithm, what you have to do is, you know that in indices we say 1 all over x is the same as what? X raised to the power minus 1. Okay, so if you have something like this, so transforming it to be in this form now, we can have log of x raised to the power what? Minus 1 to base what? 2. All right, so in that case now, this is already of this form. You can see it now. It's already of what? This form. So now you can apply the index law of logarithm, instead of saying that this particular question is another law of what? Logarithm. No. So what you have to do now is, this minus here will come down, which will have minus 1 multiplying log of what? 2 log of what? X to base what? 2. And solving this, we are going to have minus log of what? X to base what? 2 as a what? Answer. That's how you solve this law of logarithm. Okay, so let's go to the next law of logarithm, which is the fourth law of logarithm. Okay, so if you have any question, then you can do well to drop them in the comment section. All right, so we have we say logarithm of we say logarithm of 1 is what? 0. All right, logarithm of 1 is 0. So what we mean here is, let's say we have log of a to what? 1 is equals to what? 0. That's what they're saying. That logarithm of 1 to any base is what? 0. Okay, so in this case, for logarithm of 1 to any base, the base here, a, must not be equal to what? 0. All right, a must not be equal to 0. That is the condition you look at. So because if you have a being 0, it means 0 raised by 1 is equal to 0, which is not correct. All right, it's not correct. It's not mathematically correct. So what you have to do now is to check here logarithm of, so you change this to index form, where this will come here, then this will go like this. If that happens now, it will now be having a raised by what? 0 is equals to what? Then this will go like this. You have 1. Remember, when you're changing to index form, which is this form, you don't need to repeat log again. It is only when it is in logarithmic form that you need to write log. So what you are doing here now is, we have any number raised to power of 0 is equals to 1. That's what I explained in indices. So you are having 1000 raised power 0. You say it is equals to what? 1. So that in this case now, we're having a raised power 0 is what? 1. That's why you have that logarithm of 1 is what? 0. That's the fourth law of logarithm. And now the fifth law of logarithm is when they are of the same what? Base. All right, we say fifth law, logarithm of the same base, logarithm of its own base is what? 1. Logarithm of its own base is what? 1. So when I solved an example under this index form, there's a place where I apply this law. So this law now says when you have log of a to what? A is equals to what? 1. All right, logarithm of is, you see, we are having logarithm of a to base a is equals to 1. That is logarithm of its own base is what? 1. Logarithm of a and its own base is the same as what? A, which is equals to what? 1. Let's look at this to know whether if we actually got this. All right, so what you have to do now is this one, change it to index form, where we have a, then this one will come here, which is a raised power 1, then this power will go this way, we have equals to what? A. All right, so we say that logarithm of its own base is what? 1. All right, so if this is the case now, we say that any number raised to the power of 1 is what? That number. So it means that if we are having 50 raised power 1 is the same as what? 50. Okay, that's why we're having a raised power 1 is the same as what? A. Okay, so if you apply the same method, you cannot see that we're having a raised power 1. Here is also having a raised power what? 1, because we say when we have numbers that is just standing on its own, having a power of 1, that number is also what? The same as the number. All right, so any number that is standing on its own have a power of 1. All right, that's one thing you should know. If we have 100, it means that 100 is the same as 100 raised power what 1. But in maths, it's not correct for you to write raised power 1, because already we know that any number that is standing on its own has a power of 1. And if you're applying the same method here, you know that this one is also having a power of what 1. And if this goes against it, it means we have 1 is equals to what? Equals to what? 1. You can now see that any number, you understand, when you have logarithm of its own base is what? 1. Okay, that's this law of logarithm. We also have another law of logarithm, which is what? The sixth law of logarithm. We say that law of logarithm is what we call change of base. All right, change of what? Base. That is the next law of logarithm. So now we have a log of a to what? B. We have log of a to b. Okay, let me state it. Change of base. So how do you do this? You need to introduce another log. So let's say we introduce log of c. Okay, so we introduce it here. It will now be log of c. That is log of base c. You understand? So that we're introducing a new base. So it will now be log of a to base what? C divided by log of c, log of what? B to base c. Remember, whatever you are doing for the numerator, you also have to do it to the denominator. So that's why we're having log of a to base c divided by what? Log of what? B to base what? C. You can see now that the base here was b. All right, we're having log of a to base b. Now we're having log of a to base c and log of b to base what? C. So the base is no longer the same. That is a change of base. All right, we have another one where we have uh, log of log of a log of b to base a. Okay, when you solve this one, you have this to be what? 1 all over log of what? Then a to base what? B. You can see it now that we're having log of b to base a here. Then we have to change the base here where we have 1 all over log of what? A to base what? B. That is the inverse form of it. All right, this is another way you can change the base. Then we have also another law where we have log of a raised to the power of number. All right, or let's say log of b. We have log of b. All right, then a raised to the power of what? N. So in this case, there was a question we solved where we have log of b to base a raised to the power of what? P. All right, in this case, we took it this side, then to multiply the log of b. All right, then we call this the index form. But in this case now, it's not the same, because the log of b was raised to a power, but here is the base that is raised to a power. You can see it now that this is raised to a power in this case, and this is raised to a power in this case. They are not same. So you don't need to apply this same method to solve this. Rather, what you have to do when you have something of this type is this power you are having here should be 1 all over. All right. So it should be inverse of the power. If you're having log of 3, then 2 is to 4. All right. So it should now be 1 all over what 4 before you now solve. You now write log of what 3 base 2. Okay, you understand what I did there now? So this same method you're going to apply here. So it will now be 1 all over n, then log of what b to base what a. That's how to solve it. So these are the laws of logarithm that you need to apply in order for you to get whatever question that you are solving.